Okay, this is Screencast 1.2, Dimensional Analysis. Dimensional analysis is sometimes called factor label, and what we are using this technique for is converting between units of things. I did a particularly difficult example in class, so what I'm going to do on this screencast is walk us through the different levels of things that you might need to do. So, for level 1, okay, which is what I'll call these level 1 type problems. Level 1 type problems would be things like converting between, inches to centimeters or grams to kilograms. An example of this might be when you had the lab, the mass and volume lab for density. You might have had to convert kilograms to grams. So let's say I told you that you had 0.020 kilograms of gold. Okay, and I wanted to know how many grams of gold is that? Well, your first step is to figure out what the conversion, how to get from kilograms to grams. That conversion, which you should have memorized, is that 1 kilogram equals 1,000 grams. As I said in the homework assignment for the first night, on page 10 of your text, and if you have an older edition, it might not be page 10, but there's a table. Table 1.2 has the common prefixes. You need to have those memorized, the ones that are blue. Those prefixes are, I'll just write them here, mega, kilo, hecto, sorry, got my wrong gender there, deca, deci, centi, milli, micro, and nano. So you need to know what those prefixes mean and how to convert between them. So we know that kilo is 1,000, right? So 1 kilogram is 1,000 grams. So we can do that conversion. The first thing we're going to do is show the thing we want to convert, 0.020 kilograms of gold. In chemistry, we have to label the chemical that we're actually using. And we're going to multiply it by the conversion factor. Now this can be either 1 kilogram over 1,000 grams, or we could write it as 1,000 grams over 1 kilogram. Okay? And when we look at that, we need to figure out the one that's going to allow us to reduce this kilogram here to a 1, or cancel out, if you will. Your math teachers don't like me to say cancel out, so I'm going to say reduce to a 1. The one that does that is the one that has the kilogram on the bottom. So 1,000 grams over 1 kilogram, so I put that one in down there, will allow me to cancel out or reduce that to a 1. And now my unit that's left over is grams of gold. So 0.020 times 1,000 is going to give me an answer of 20. Now, this is an exact number, so it has infinite sig figs. This has 2 sig figs right here. So my answer needs to have 2 sig figs. My answer is 20 decimal point grams of gold. So that's sort of level 1. That's the easy stuff. Level 2, and if you're looking for examples of these level 1 conversions, you're going to want to look at example 1.5 on page 19, and then exercises 1.41 and 1.42. This is more practice, okay, in your chapter. These are places where you can look for additional practice when you're getting ready for quizzes, tests, or just needing to practice things or have questions. The second level would be something more along the lines of multi-step conversions. Now I'm going to give you an example of a multi-step conversion from your text. This is unit conversion example number 1.7 on page 20. I would not do this conversion this way because I happen to know how many kilometers are in a mile, or I can get close enough because I know that a 5K is 3.1 miles. So I have a conversion factor I've sort of memorized in my head. However, if you were told in a problem that if 1 kilometer equals 1,000 meters, which you should know because kilo means 1,000, 1 meter is 1.094 yards, and that 1,760 yards equals 1 mile, and then asked to convert 10.00 kilometers to miles, you would use these three conversion factors, starting with your 10.00 kilometers, multiplying times your first conversion factor, which is going to get us from kilometers to meters. 1 kilometer is 1,000 meters. Then you're going to look at 1 meter is 1.094 yards. And finally, 1,760 yards is 1 mile. Noting that I'm not doing any of these steps independently or rounding, I'm going to type this all into my calculator. If you're curious about how I would do that, I would do this. 10.00 times 1,000 divided by 1 times 1.094 divided by 1 times 1 divided by 1,760. Then I would hit equal sign. And the answer that I would get would be 6.22 miles. And I'm going to look to check. I have 1, 2, 3, 4 sig figs here. So my guess is, even though your book said 6.22, unless it comes out, I hope it comes out to be exactly 6.22. Oh. Interesting. There's a mistake in your book. Your original giving to you is that it's 10.00 kilometers in the what do we know, but it's actually given to you as 10.0. So that's 3 sig figs. So we're going to round our answer to 3 sig figs. You'll notice in these videos, I'm not a perfectionist. I'm just going to sort of talk my way through them as I would have in class. So if I find mistakes, I'll point them out to you. In the problem that's given, the example on page 20, it's told different ways in the problem. The first time they give it to you is 10.0. The second time it's 10.00. So just note that's incorrect. That's a typo in your book. But originally they say it's 10.0. That's 3 sig figs. Each of these is an exact number, so that's infinity of sig figs. So our answer must have 3 sig figs, 6.22 miles. Okay, so that's a level 2 type problem, multi-stepped. A level 3 type problem would be something like I did on the board today in class. Let me give another example. That's going to require you to remember some stuff from Intro Chem about molar mass. We will be getting to dealing with molar mass again in chapter 3 when we talk about the mole concept in Stoic, but let me give you an example that just has to do with atoms. So let's say I have 15.3 grams of zinc. I don't know why I have it, but I do. 15.3 grams of zinc. I want to know how many atoms of zinc that is. The conversion factor I'm going to have to do, I'm going to have to go from grams to moles to atoms. Okay? Now the grams to mole conversion is straight off the periodic table. It's called the molar mass. And for zinc, if we look at zinc on the periodic table, which I'm doing right now, I notice that zinc, which is atomic number, I'm going to find it. I would have planned ahead if I'd known I was going to choose zinc in my brain. 30 has a molar mass of 65.39. Okay, so this number down here is our grams to moles conversion. That's going to be our first one. So I'm going to start with 15.3 grams of zinc times my first conversion factor, 65.39 grams is 1 mole of zinc. Notice I'm always adding the atom here. I'm doing that for record keeping, so when I get to stoichiometry, I have my records. And then I'm going to say, all right, now I need to get to atoms of zinc. 1 mole of zinc is 6.022 times 10 to the 23rd atoms. 1 mole, if you're unfamiliar or don't remember, is always 6.022 times 10 to the 23rd. It's kind of like a dozen. If I have 1 dozen bagels, I have 12 bagels. If I have 1 mole of bagels, I have 6.022 times 10 to the 23rd bagels. Okay? Doesn't matter what you're talking about. 1 mole is always 6.022 times 10 to the 23rd. So what I would do in my calculator then is take this 15.3 times 1. You don't have to do the times 1, obviously, but just for record keeping, I'm doing it right now. Divided by 65.39 times 6.022 times 10 to the 23rd. I would not use the times button here. I'd use the EE button. If you do not know how to do scientific notation on your calculator, you need to see me, and I need to show you that because you will use it a lot. And then divide it by 1. Okay, so hit the equal sign, and I don't know what that is because I haven't actually calculated it. Let's give it a try. Okay, let's get to my scientific calculator. So I'm going to take 15.3 times 1 divided by 65.39 times, I'm going to put a parentheses around it, 6.022. Don't know where the E button is here. I'm going to guess it's that. Yeah, there we go. 23. Close parenthesis. Divided by 1, which I'm not going to do. All right, so now I've got this big, huge number, and I'm going to take it, and I'm going to go 6.022. Let's bring back my calculator here. There's my answer. Okay, so this was not my answer. Wish I could make that show up at the same time. So 1 point, let's see, I have 3 sig figs here. The rest of these are all exact. So I'm going to say that that is 3 sig figs. So 1.41 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 1.41 times 10 to the 23rd atoms. There's my answer. So you'll notice all you really need to do to show for work for this is this part and then this part. Okay, so write that out, show your cancellations, moles, moles, and then give me your answer. Type it all in your calculator. You don't need to show all this stuff that I do. Okay, that's just for me to explain to you. All right, that'd be a level 3 type dimensional analysis. What I put on the board today is probably level 4. We'll get to it later. I just wanted to show you an example of showing work, and I came up with a pretty hard example, I know. So don't freak out. Start with level 1, do some practice with that, which I have assigned for this evening. Try some level 2s, and try some level 3s. Work your way up with dimensional analysis. I will, at the end of the class period tomorrow, give a formative quiz just to check and see where we are. Remember that formative quizzes are things that you take for 2 reasons. First, to get an idea of what you still need to work on, and 2, for me to get an idea of what you still need to work on. You're given a feedback score, but that doesn't count as part of your summative grade. If you are still freaking out about dimensional analysis, do some practice. If you get stuck on a question, write down a question that you need answered in order to move forward so that you have something to contribute to a discussion with me. And then I would say take a peek at the Schoology assignment. I've given some practice problems. I would also encourage you to look at temperature conversions, especially those related to kelvins. Okay, we will need to, in this class, convert most temperatures to the absolute scale, which is the Kelvin scale. And it's a pretty easy conversion. We just got to know what we're doing. And there you go, Screencast 1.2.